Hi students, let's look at this question which was taken from the year 2015 paper 2 question 9. I think this question is on probability. So for events A, B and C, it is given that PA is 0.45 and PB is for 0.4, 40% and PC is 30%. So PA intersect B intersect C is 10%. It is also given that A and B are independent. Now when this is independent, it just means that PA intersect B is given by PA multiplied by PB. Okay, so this is by definition. So and the events of A and C are independent also. So this will also mean that we have the license to use this formula. A intersect C goes to PA dot with PC, right? So P, I think the first one is really quite okay. So you just want to find PB given A already happened. So this is PB intersect A, PA. Okay, so this case here, this will just be PB, right? Okay, because A and B are independent events. So this will just means that PB happening, it will be at the same odds, regardless of whether A happens or not. Okay, so you could just substitute this in, you get the 0.4. Okay, so that's that. So let's look at part 2. Part 2, we are told to find A intersect B intersect A complement intersect B complement intersect C complement. Okay, so what I'm going to do, I'm just going to draw a Venn diagram. Okay, so from here, A, B, and C, you know that A intersect B intersect C, intersect A prime intersect B prime intersect C prime will be outside here, right? This is the area that we want to find, right? So in other words, for part 2, what we need to find is PA intersect PA prime intersect B prime intersect C prime will just be 1 minus PA union B union C. Okay, so we were also given that the B and C are independent, meaning to say we could use P B intersect C is PB times PC. Okay, so this case here, this formula here, we know that this is nothing more than just you take PA plus PB plus PC, right? Then what you need to do is just minus of PA intersect C minus of PA intersect intersect B if you want in the orderly fashion. So PB intersect PA intersect B, A intersect C, and then PB intersect C. Then you add back the middle part. So this guy will be plus PA intersect B intersect C. PA intersect B intersect C. All right. Which we have all these values here because we know that PA given in the question was 45%, so 0.45. PB given the question was 0.4. Then 0.4 plus PC was 0.3, right? Then PA intersect B, we were given that is PA. They are all independent events. So intersect A intersect B will mean that you just take A times B because they're independent. So 0.45 multiplied by 0.4. A intersect C will just be 0.45 multiplied by 0.3. This B intersect C will be B multiplied by 0.3. Then add back A intersect B intersect C, which is 0.1. Okay, just add it back. So 0.1. Okay, add them out, should get the answer. So this will give us 1 minus 0.815. Then in turn, this will give us 0.185. Okay, so that's how you do part 2. Let's look at part C. So let's look at part 3. Part 3, given instead B and C are not independent, so now we know that B and C, the relationship is not fixed. Find the greatest and least possible value of A prime intersect B intersect C prime. Okay, so this case here, I think a lot of times, okay, I will use the model method because it's easier. I think this will be easier. So you think about it, you have the relationship between A, B, and C. You know that between A and B are independent, so this is fixed. A and C is independent as well, so the relationship is fixed. Now what is not fixed is the relationship between B and C. This is the one in the flux. Okay, so usually what I'll ask students to do is you just consider this two area first, then you bring C in later. Okay, so you decide all the relationship between A and B in the Venn diagram. So this case here, I'm gonna just put A and C here. So now I'm gonna just write down PA. We know that PA intersect B is because they are independent, right? So essentially, this case here, what we have is A times PB. So this will be 0.45 multiplied by 0.4. So here will be 0.18. Okay. So then we think about the crescent here. This crescent here. Okay. This crescent here will just be PA, the entire thing, minus of the intersect, right? So essentially, PA intersect B prime will just be PA minus of PA intersect B. So you just take PA, which is 0.45 minus of 0.18. Just key in calculator. Okay, so you do similarly, you just find out what's this crescent here. In this case, it will be 0.22. Okay, then you think about the area outside. So the area outside will just be 1 minus the entire thing A union B, right? So this, you just take 1 minus 0.22 minus 0.18 minus 0.27. So this step is crucial. Okay. Now once done, what we can do is actually bring C in, right? So you know that the relationship between A and C is fixed. Okay. How fixed is fixed? Essentially, the A intersect B, the area is essentially fixed, right? Between A and C. So now when C comes into the picture here, so let's say this is C, right? You know that this area is fixed. Yeah? This between A and C is fixed. So this PA intersect C will just be PA times PC, okay? Which is actually 0.45 multiplied by 0.3. 0.135. Okay, then after which you know, because PC is 30%, so this area here is also, so this area here overlapping this area will be this entire thing will be 0.135. So because PC is 30%, so you take 30%, you find it out what is this area here, which is actually 0.3 minus 0.135. It'll be 0.165. Okay, there you go. So generally when you see this is 16.5%, right? So this 16.5% actually will swing in and out of the diagram. So like that, and like that, okay? So minimally, actually this 16.5%, you could actually, this 22% could actually accommodate 0.165. So case number one, that will be when A prime, so case one, where it's A prime intersect C will be a subset of B. So this is where, if this is C, all right, this entire thing, 0.165 move into B. So this will be 0.165 over here. So this is B. Okay, remember, the area outside B and A, they are the same. Everything is the same. So this case here, outside is 0.33. Okay, so because you want to find the greatest and least possible value of the outside of them, outside A, B, C. So this will be the greatest value. So hence, the probability of A prime intersect B prime intersect C prime will be 0.33. Okay, this is 0.33. Then after which you think about it, you need to actually think about the least possible value, right? So essentially C, 0.65, can also swing entirely outside here, right? Where B and C are mutually exclusive. Because outside is 33%, you can totally accommodate A prime intersect C outside of A and B, right? So this is how it looks like, right? So imagine this thing swing entirely outside. 0.165 will be here, okay? So because it will eat into this space here, the 0.33, outside 0.3, so the outside here will be 0.33 minus 0.165. Okay, so this case here, PA prime intersect B prime intersect C prime will just be 0.165 and 0.33. Okay, so that's it. So this would be the greatest and least possible value. Okay, so that's how I do this question here proficiently. If you have any questions at all, please do let us know, and I'll see you in the next question.